Hello.
Hello.
Hello. So, who's here?
So we got Martin, Piper,
Hello.
Aaron, Casey. We're still missing Vlad
Hmm.
Jeff.
and Jeff. All right. There's that. Let me go
Yay.
find.
Okay. So the next question, the next sort of specific question I'd wanted to get through was, should the mechanism for paying transaction fees for bets be inside of the Casper protocol, or should that kind of be outside, or inside the Casper contract, or should that be separate? So now that I think about it, so in general, if you make it separate, that kind of makes it more general. If you make it in Casper, that makes it more efficient. One other thing that I thought about was that if you make a bet and that bet doesn't have enough of a transaction fee, then you might need to kind of replace by fiat in order to get the bet in. And doing put fee inside of Casper kind of makes it easier to do that. So that too kind of makes me lean more toward just putting the fee into Casper.
So you already decided, Vitalik, to have the validators pay a bet inclusion fee?
Yeah, basically, well, a bet inclusion fee of their choice. I mean, theoretically, we might decide to have some other kind of incentivization model, but I think actually, if we put it inside of Casper, then actually the mechanics should be simpler to switch to something else.
Yeah, I'm not fond of a fee market, but what about subsidizing bet inclusion by sharing the bet, the scoring rule bet reward with the validator that includes the bet?
Yeah, I could do that, but that's basically a mandatory fee.
Okay, so a mandatory fee, I guess I would prefer over a fee market.
Why?
But the other thing is that it discourages you. Say there's like a bet that leads to someone losing their deposit. Like, why would you ever include that?
Right. Well, the answer is that you give the includer the absolute, like say 0.5% of the absolute value of the scoring reward instead of just the so well, if it wins you get some, if it loses you get some.
Right. And then like the bigger the payout,
Yeah, pretty much.
It's straight out of the protocol.
You could do that, but I'm just wondering like why not have a fee market? Like
because,
what does a mandatory fee provide?
And I just worry that a fee market introduces all kinds of strategic gaming opportunities to.
But the thing is that those strategic gaming opportunities still exist because there always is a fee market. Like validators can always make side channel payments.
Yeah.
Makers can always make side channel payments.
But we can't enforce a minimum fee.
Well, no, you can't because you could potentially have validators making side channel payments to bettors in exchange for bettors sending their bets directly to validators, so the validators would have a chance to include them.
Yeah. But we can't enforce a minimum.
No, well, you can't. Unless the minimum is like just a reward that comes out of nowhere.
Well, no, the minimum, you can enforce a minimum fee by just taking that the fee is paid at the protocol and redistributing it to everyone, so that.
Well, hold on. What do you mean distribute it to everyone?
So imagine the fee goes. Some of it goes to the.
So first of all, what's the function? Remember, the function of the fee is to incentivize including the bet.
Right, but if you distribute the fee to everyone, then you do have a minimum in the sense that like the person who's paying is actually going to have to pay something, unless he has all the validators agreeing to refund him.
Well, hold on, but I think we want to make it as cheap as possible for the bet sender to make bets. Like I've done the math, and if you treat the bets as normal transactions, then the amount of fees that they'd have to pay is actually over the course of like a 4-month bonding cycle is actually pretty high.
But they're paying it to themselves.
They're not paying it to themselves. You're making a fallacy of composition. Different validators are paying fees to different validators.
That's what I mean. Yeah.
Yeah, so you can't say they're paying it to themselves.
No, I know, but they're going to get a revenue in transaction fees.
Right. Oh, I see. You mean in
Because
aggregate? Yeah, I mean in aggregate, I suppose. But the thing is, I mean, there's still a bit of an inequality risk because if you're a richer validator, then you get a larger portion of the transaction fees, whereas everyone has to pay the same amount.
that's very true, but there is a reason why we'd want everyone to pay the same amount because everyone is causing the same amount of overhead.
Yes, agree. But I'd prefer to compensate for that somehow.
hmm the only way to do it is to have the way that people are incentivized to include bets being
So
given by
one
the
thing that I'm actually considering is just subsidizing the gas inside of Casper by like either 75 or 90%.
anything that happens in Casper, so like the bets,
Yeah.
basically bets.
Yeah.
Yeah, that makes sense. I mean, but it seems like a small thing.
Yeah. Okay, so my only concern then is like, first of all, why even bother with mandatory? Like, I'm still not convinced as to why mandatory fees have any value at all.
Well, why does a block reward have value?
So remember, a block reward is paid out of nowhere. A mandatory fee is paid from one entity to another entity. They're completely different.
Yeah.
But if you subsidize the bet inclusion fee from the block reward, then it comes from out of nowhere, just like the block reward does.
Well, hold on. By subsidy, I mean subsidy in the sense of gas, not in the sense of ether.
Okay, well, I mean in the sense of ether, just like the block reward.
Right. Oh, so you're saying basically why not subsidize including a bet and have that subsidy come out of nowhere? Yeah, it's possible. I'd be fine with that.
And the reason to do that would be for the same reason that blocks are subsidized with a block reward.
Yeah. Okay. Yeah, I'd be fine with that.
Oh, Jeff, this is terrible. You didn't even you sounded like buzzing or something.
You sound like a bee hive.
Yeah.
Okay, so one concern is that with just a subsidy is that, well, actually, I suppose you could allow the subsidy to be complemented by fees if someone really wants to. And you could make that fee payment mechanism out of band, I suppose. Okay, yeah.
The other thing is to use disincentives. We're basically like, okay, we expect there to be a certain number of blocks produced at every height, and therefore, if your bet does not include that amount or more, then if your block does not include that amount or more, then you will be penalized.
I don't know. I don't like that approach because it just seems a bit like the number of blocks at every height seems like it's a pretty erratic statistic. Like in my simulation, sometimes it's 5, sometimes it's 0, sometimes it's 1. It's kind of weird.
Oh, but I'm not relying on that. I'm talking about the number of bets at every height.
Yeah, I'm saying that at every height, the number of bets is sometimes 5, sometimes 0, sometimes 2.
Oh, okay. I thought you said blocks. Yeah.
Yeah, no, I might have said blocks, but I was wrong. I meant bets.
Okay. So that's potential concern, but I do prefer using disincentives than magical protocol rewards. But
remember, we could just charge a constant size tax, and we can turn a magical protocol reward into a disincentive.
Vitalik, that differential number of bets at each height, does that come out to a consistent average, or is that like truly...
Yeah, I mean, on average, you basically get V over 6 bets at every height, where V is the number of validators.
And you just only have the validators betting every 6 heights, right?
Okay, so if you want, what you could do is, let's say if there's right now there's n validators, then what you could do is you could provide a subsidy of, let's say, Q for including each block, and then you create a subsidy of and then you create a tax of, let's say, Q times n over 6. And that way, if you include more than the average number of bets, you get more. If you include less than the average number of bets, then you lose a bit. So I'd be fine with that.
Yeah, and so I kind of like that, but again, I generally prefer rules that have conservation of ether, right? Where ether is never created. Or
yeah, so like if we want, we can set the tax to have like rough conservation of ether.
Yeah, but it would be rough. It wouldn't be like strictly every payout is actually coming from somewhere.
Yeah. I mean, okay, if you really want, what you could do is you could just give the Casper contract a balance, and you could have the Casper contract automatically like reduce its payouts and increase its penalties if the balance drops below a certain amount.
Yeah, so
So the way
that's basically what I have in mind, right? Where everyone puts their bonds in the Casper contract, the Casper contract collects all the fees, and then like people can get some amount of money out depending on what happens.
oh, you're having the Casper contract collect? You mean the Casper contract collect for transaction fees?
Yeah.
Oh, I don't do that. Basically, because
So that depends on if I have a transaction fee policy or if the fees go directly to the person who created the block.
right. Well, I mean, I have fees going directly to the person who created the block, but the mechanism is kind of up to the individual.
Hey Greg, we have a request for the YouTube link. I'm not sure if you saw that.
I saw that. I'm giving. Yeah.
Okay, so it sounds like we have kind of rough consensus.
Yeah. But without the Casper contract getting any fees, basically the Casper contract would basically like take in the bonds and pay out bonds, and the most validators would basically, expect everyone would basically expect to get slightly less than they put in, but they hope to make it up in transaction fees that they get from producing blocks.
Yeah. Okay. No, so I'm satisfied on that issue. Um,
Um, last time we talked, there was an issue that you raised that we haven't covered yet. So there's the betting cycle conversions, there's the bond on bond policy, and then there was one more, wasn't there?
hold on, bond and bond. Let me just go up. There was scoring rule stuff, but I don't know. I feel like that's just something I'm gonna have to figure out. Let's see. Then there was the concept of like allowing validators to bet on many blocks at once if they want to, instead of betting on each height. But
Right.
personally, I don't know. The concept of betting on state roots does kind of also satisfy me.
Yeah, but don't you already include making bet only every 6 heights?
Yeah, I do.
Okay, but that's different from not having everyone bet on every height.
No, sorry, I meant, but like if the protocol fails to come to consensus in time, then like the bets kind of drop off, and you have to just bet on state roots.
Okay, yeah. I mean, I think that seems to be the way to go.
Hmm.
Wait. Where's the magic number 6 from? Sorry.
It's just a
It's
constant.
an arbitrary constant. It can go up or down.
It's a constant factor like reduction in the overhead.
Well, not quite, because remember, it reduces the signature verification overhead,
Right.
but
So
it doesn't reduce
right.
the processing bet overhead.
Factor in the signature verification.
Yeah.
Yeah.
But the question is, I think Greg was asking is why the number 6 over
It's a
7
reasonable
or
balance.
9?
Basically, if you push it above 6, then the efficiency gains are pretty small, and the cost is that the blocks end up taking a really long time to finalize.
Yeah, I mean it's bad. It's bad that we have a number to argue about. There's just some number there. We don't need to argue about it.
Yeah, exactly.
So the only strand of the conversation that I know that someone wants to revisit is the whole lexicon around scheduling, or maybe the philosophy around scheduling versus blocks versus state.
What do you mean by
Right.
scheduling?
The simple
Oh,
argument
you mean
is
the timestamp thing?
Sorry?
You mean the timestamp thing, or?
No, I mean. So for me, in my kind of language, blocks propose, some little orders or maybe partial orders of transactions, and then and then we take a whole bunch of blocks and that information and translate that into a schedule, which we would then use to get a state root
Yeah.
or a set of transaction receipts. And basically, I have an indirection. I have indirection between the order that is observed and the order that is scheduled, and I think that is the source of Greg's concern.
Right. Yeah. So well, by order that is observed, what we mean is the order on convergent chain of bets agrees to is not the order that is affected in transforming a state.
That's right. That is exactly what I mean.
Okay. So there, I mean, I would be perfectly happy if there's some, equational chain that that says, all right, you start with this order, you apply this operator, you get to the next order, you apply this operator, you get to the next order, etc., until finally you arrive at the order that, and everyone agrees.
But you want
that
the state to not change through those operations.
That's right. That's right. Because otherwise,
Right.
people
So I'm
will
insisting that I'm
not
insisting
participate
that yeah. So I'm insisting that actually for my scaling layer that there will be a change sometimes. It's not going to be necessarily always.
I'm gonna have to head off
so
right
hang
now soon.
Okay.
Let me just address the concern, right? So if when we have a tangle of transactions that are all essentially part of what I would call one transaction, then that's part of an equation. That's what I would consider an equational transformation. And
But
so
handling is going to make it into two transactions.
not if there's a causal loop, right? If there's some like if you have a recursive contract or if you have a pair of mutually recursive contracts.
So what I'm doing is I'm breaking.
Then you have
the
to
causal loop.
you can't break them. You treat them as though they were part of one Uber transaction.
No, but you can't do that because that Uber transaction is growing indefinitely.
No, it'll run out of gas, as you said. It'll never grow indefinitely.
Each of which are paying gas, right? So you call it one transaction, but really it's many transactions that are interleaved, and that you each one of the transactions will run out of gas, but the set of transactions that's 10, because you can keep funding it, and you can keep pouring transactions into there.
I can't. I got every 10th syllable. Can you say that one more time?
So was made up of an increasing number of transactions, each of which runs out of gas, but each of which introduces more gas. So you can have a growing spiral of transactions that just grows it indefinitely. And so I really do need to do some state affecting reorgs in order to prevent this tangle from being essentially unfinalizable.
So we had this discussion, 2 weeks ago, and that was exactly the thing that I was concerned about with respect to compensations chasing transactions that were affecting changes that shouldn't be. In other words, you've got some error correcting process that's chasing after some process that's committing errors.
Reorgs propagate fast enough to it's not like the chase isn't going to end, right?
Yeah.
Why?
Because reorgs and reversions go faster than execution.
Okay, so I am heading off now. So see you around.
It's been nice, V. We'll chat soon. I'll see you in Boston.
Yep. See you then.
Yeah. Ciao.
Yeah.
So yeah, so it looks like we have a longer discussion. I'm happy to. I'm not sure that we need to resolve it today, but it looks like there's a longer discussion to be had.
I'm happy to chat for another 15 minutes and then go grab lunch, and then we can maybe have another conversation if you'd like.
Yeah, we can conclude. We can conclude now. I mean, I'm not particularly miffed or fussed about the nomenclature you proposed. That seems reasonable, but there are some semantics that I'm concerned about that that we're still sort of having discussions about. So the semantics of observable order versus actual order, I think. Certainly,
observe.
never ever.
I use observed and scheduled, and basically I schedule things slightly differently than I observe them. Rarely, but only and only uh, when it's necessary for finalizing stuff. Um,
Right. I
and
mean, this is
they,
like a pipeline of computations on a chip, right? I mean, the observed order of operations, the scheduled order of operations in
yeah,
pipelines on chips. That's well understood. But there's always this requirement to preserve correctness, right?
of
I mean,
course, of course,
you
of
would
course.
never like no, every programmer would be like tearing their hair out if like their programs had different outcomes than what were legally allowed by the
I mean,
meanings of the operations of the
totally. And
programs.
I make I put correctness, and atomicity of transactions as my highest priority. I do not sacrifice on that at all.
Okay, so then I think we're probably on the same page, right? It's just that every reorder has to preserve some semantics,
Of course.
some. Okay,
Which
then
is
we're
namely that the transaction receipts and the effective transactions are precisely given by the application code.
I didn't get the last little bit. The
Um,
effective transaction receipts and then blank.
so the transaction receipts and the effect of transactions on like state is precisely given by the application code, right? By like the complete execution of transactions against application code.
Okay, then that I would express that as there's a chain of equations from state to state.
Yes, but the say if we were just to play the observed order of transactions and calls, we might get a different state than if we play the scheduled order. But both states will be the
Then
results
you
of the
can't
correct
make
execution of transactions against applications.
the claim about the correctness
No, I
with
can
respect
because
to
it's
application
just
code.
basically a reordering.
I think if this is a helpful, since I think I'm understanding both of you, I
Wait,
think
wait, wait, wait.
Vlad is only enforcing correctness at the transactional level, and Greg is trying to get correctness at the multi-transactional level.
I'm super concerned that what you're saying is that application logic can expect one state and see another. That's what I.
um,
If
I,
that's what you're saying, then that would be really, really worrisome for any application writer.
so the only case in which they can expect something and then get something else is the case in which there are some costly reorgs or something like that for the because of basically unreliable networks or bad validator behavior. Um,
Which,
the
for the record, Greg, is the current situation with all existing blockchains. Costly reorders can break the expectations of the application.
But the application that's in the chain is also being reordered, and so its logic is being respected on both the new and old order. But say that if a client interacting with it might have one transaction receipt and then end up with another one after the reorder, even though in both the transactions are atomic in the sense that the transaction was executed completely and correctly against application code. The difference is the order in which the transactions are applied.
Wait, can I just ask a clarifying question? This is about reordering transactions that are within a block?
This discussion also applies to that, but it is more general because I'm talking about reordering transactions across shards.
Okay, got it.
In a scaling situation.
But you say you want to only reorganize if you have to because it's still because you can't finalize.
That's right, and that's an artifact.
Would you identify? I mean, how would you identify those situations or prove that you were in that situation?
Right.
You were
So
allowed to reorder?
I actually don't at the moment. But that's the only time I strict. So basically, I actually don't. So I actually do some reorgs that aren't necessary. But because I have a really simple protocol for doing it, and I can just like show that I detangle when I need to, and then I might do some reorgs even when I don't. But I would like to do that but then I would need an algorithm for figuring out where it's necessary.
That might be computationally very hard.
Yeah. Right now I'm just doing a regular event that I reorg around in order to make sure that any transactions that gets in before the event finishes before the event, and any transaction that gets in after finishes after, even if the transactions have effect that cascades across many shards. But this is very very well pointed out, Aaron. I kind of misspoke.
Yeah, I mean, in general, this is like like a memory barrier, right? You're just dividing. You're saying there are certain operations that occur before this event and are known to occur before the event, and other operations are on the other side of that. Yeah.
That's right. And the reason that I have a difference between the observed and scheduled order is because I first observe some order of things, and then we agree on where this event will occur, and then we reschedule things, and then we kind of.
I mean, like every programmer and their brother and sister are perfectly happy with the idea that operations are going to be reordered underneath them, right? I mean, whether you're writing in C or you're writing in Haskell, every programmer accepts that fact, right? That's been the case for a long time now.
Okay,
but what every programmer is also expecting is that the reorders don't change the semantics, right? Unless there's a failure situation, right?
Right.
But in that case, their program is told about the failure, and they can take appropriate cleanup steps.
That's right.
What I'm concerned about is.
So here we have.
What I'm concerned about here.
I'm getting a lot of echo. Sorry.
Oh well, I can mute.
Oh, I'm sorry. In my so I think I get exactly that, and namely that for the application's code is always going to be the thing that generates their transaction receipt, and that generates any state changes, and that will never be violated. But a user of a transaction might, because we do optimistic execution, and then we might do, then we later will have a new schedule. The user might see one output with some assurance, and then get another one that updates it. But each one will be the result of correct execution of transactions against applications. And so basically what's going on is that the scheduling is happening after the optimistic execution. So first we optimistically execute, and then we might have some schedule change, and then execute again. But in each transaction receipt, you're going to have correct execution of transactions against applications. So you're going to have, like, the developer isn't going to be surprised about their semantics being violated, right? Because the semantics of their application in this environment.
Yeah. So we've had this discussion. So by operations here, you mean essentially non irreversible operations.
That's right. Yeah, I'm talking about the non-finalized operations.
No, but even it's about irreversible, right? You couldn't ever include irreversible operations.
Finality means non-reversible, right?
No, because if you're running stuff again and one of those operations is launch the missile, you don't get to run it again because you run out of missiles.
Oh yeah, well you don't launch the missile until you have a finalized transaction receipt.
Right, but that's what I'm saying. You're going to have, every application programmer has a requirement to divide their application into irreversible and reversible operations.
That's right.
And the only operations they ever. Right. Okay.
Although the way that it's gonna work is in practice. So for example, 6 Bitcoin confirmations are reversible, but people will take irreversible operations based on six Bitcoin confirmations, even though their 6 confirmations they know can be reverted by someone who will make a competing chain with 7 blocks that are competing with theirs. So
yeah, no, I understood. This is a different kind of semantics than many than exists in most computation today, right? Because there are lots and lots of irreversible operations that happen right up against the metal, like forgetting,
Right.
Once you clear out memory, you don't get a chance to go back unless you recorded that memory state somewhere else.
That's right. So for
Right.
us,
So
finality
so
is
so
the time when you can really forget.
Right. I think
right. Exactly.
there's no way philosophically to get around the fact that decentralized interactive programming is adversarial, and that you can never completely remove that element at the protocol level. And I think that is something that programmers do have to add to their existing assumptions. Like you have kind of assumptions of non-adversariality at the scheduling level inside of most like hardware and stuff. So that is a new change in the philosophy, and there's absolutely no way around it, no matter how you design the protocol.
Yeah, totally.
Well,
Although
is
I
there
would add that some reorgs and some changes in transaction receipts will be a result of like network stuff, and some of them will be a result of adversaries.
so could I protect myself
Potentially
against that?
cause these transaction receipts to change, and
So-
certain application will need to care basically on how much it would cost people to
Yes.
for your transaction receipt to be false.
Yes, exactly. And Aaron, yes, you absolutely can protect against that in your application design, and you
No,
have
I
to
meant-
show,
The way you protect it.
Well, so the way the way I understood one of Greg's concerns, I hope I'm getting this right, is that if I make a transaction or an interaction with a program based on what I think the state is, and then stuff gets reorganized, so I'm actually interacting with a different state of my program, I might lose out. So I was asking, is it possible that I could send a transaction to some app or some contract, but I make this transaction only be valid if it does find the contract to be in the state that I think it's in? And if
Yes.
some reorganization makes it a different state, then the transaction becomes invalid.
Yes, you can do that at the cost of asynchronicity.
And it becomes very difficult to do in a scaling situation, because in a scaling situation, you will not even know the state of your application before you send a transaction to it, because that application exists across many shards, and you don't actually have, there's never a global state of that application. So you can't say this
at
must
the
be
protocol,
the
at the
application.
protocol
You never
level,
know.
sure. Sorry.
So your account though is just a contract, or we can consider your account to be a contract, correct?
But the DApp you're talking to is not just a contract. The DApp you're talking to 50 contracts.
Right, sure. But to some extent, though, you can do what was suggested. Like, you can run a transaction against a certain state, but it has to be contracts that only are mutable by few parties, like your account.
Yeah, exactly. So that's what I'm saying. In sharding, in scaling, it becomes harder and harder to do this.
Okay, but there's two levels here that I think people need to kind of keep in mind. So there is protocol level decisions, and everything Vlad's saying is totally right at protocol level. But at application level, you're designing for adversarialness. So you're including things like if you want to handle the situation where you want to execute only against a specific state, you build that at a meta level in your application, and you do it in this asynchronous fashion where you choose your subjective risk level, and then you build your application to detect when that level of confidence that state is the case is so. Like you can build it back in. It's just at the cost of being heavily asynchronous.
Yeah, I mean, I totally agree with you, Jeff. I think that this needs to be handled at the application level rather than at the protocol level, because the protocol can't provide you with this type of guarantee, especially in a sharding situation. In a situation where for example, like Tendermint, for example, where there is no forking and you could always basically know the state, you might be able to do at a protocol level special transactions that only execute if the state of the overall system is this. But as soon as you go into availability favoring protocols or scaling, you need to all of that logic needs to be pushed to the application level.
So I think we've covered most of my concerns. So I believe I understand what you consider to be reasonable reorgs. I need to look at the details of what some of the reorgs that don't preserve state look like. I believe that all of those are classified as failure cases. in which case you can alert an application that essentially the state that it was expecting is not the state that it's going to see.
Yeah, but I think it very much matters whether this piece of the application that you're alerting is in the state that's being reverted or interfacing with the state that's being reverted. Right. So your application is going to have like a piece of software on the client side and a piece of software in the blockchain. The piece of software in the blockchain won't necessarily be alerted, and it's always going to have correctness as far as it knows, because it's in basically like this matrix that doesn't know that it's being reorged, because at any point it is just the result of some schedule. And then there's the application that's watching this stuff from the client side and is seeing transaction receipts change as a result of these reorgs. So basically, when you're inside the matrix, you can't tell that these reorgs are occurring. When you're watching the matrix from the outside, you need to be alerted, and this is going to be like a failure mode.
Right. I'm only talking about those things on the other side of the observability boundary. Right. So a client will be able to observe that, for example, that a particular bet was or a particular sequence of bets converged, and then they'll be able to, which has implications about state, and then they'll be able to observe that that state never actually arose, and so therein lies the concern. And as long as that state never actually arose, is labeled as a failure, then everyone will be happy. If that's labeled as normal operation, nobody will be happy.
I totally.
Right? Because would that mean?
I totally am on the same page as you are. The main reason I think we keep having this disagreement is because when I say application, I'm thinking about code that is in the matrix, and I'm not generally thinking about code outside the blockchain that's interfacing with stuff from inside the blockchain. And the reason
but that's
is because the protocol that I'm designing only really addresses at the moment the atomicity of the transactions with respect to the code that's inside the blockchain.
Right, that's exactly what that's why I'm looking at this case. I'm looking at this case because the observability boundary is right there between those applications that are using the blockchain and those applications that run some code in the blockchain and some code outside of the blockchain.
Exactly. Yeah.
We know that's interesting, right? Because
I totally agree with you. I think that's super important.
Right. The reason that's interesting is because we've already argued irreversible operations that are at human scale are going to be irreversible, right?
Totally.
That's what all the financial, right? So most of the semantics is outside of the protocol.
Yeah, and this is also why I've focused so much on getting transaction finality, because I know that lots of use cases are going to require transaction finality. But I also am interested in figuring out what is the most sensible way to what can we do from the point of view of the application development environment to help people deal with the fact that transaction receipts have this essentially sliding scale of guarantees of not being reverted.
So
right,
I actually think, like, now that I'm considering this carefully, I actually think that you can get everything you want, Greg. So I think that what you can do is you can just do the error handling inside of the contract on chain. So basically, you build your conditional checking inside of the contract so that it has an operation. It retrieves the state, it checks the state against something, and it does whatever. And then if the protocol reorgs that, then its retrieval will be different, and it will actually know that it's not the state that it intended. So I think you actually can get everything you want.
Yeah.
I agree. The only thing I was hearing was that some reorgs that didn't lead to the same the difference in an observed state with respect to convergence of betting versus this, the state that the application actually dealt with.
Right.
If that isn't treated as failure or error case, right? That was the part that I was concerned about.
So I think the reason that there's a little bit of confusion is
Go ahead.
the betting has like multiple stages here, right? So there's betting on the observed order, and then there's betting on the scheduled order, and then there's betting on the state. Certainly, the betting on the state will never be like once you have you're not going to get failure off once you have really strong bets on the state. But we're going to finalize the observed order before we finalize the schedule, before we finalize the state.
Yeah. Mm-hmm.
And I just
that's interesting.
Mention one thing also. What you can do from a software side point of view, like client side software point of view, is only ever treat receipts that are finalized as valid. And that for some applications will be totally appropriate. But for some applications, you will want to treat some receipts as valid before they're finalized, some of them even before they have any finality guarantee whatsoever. For example, one of my favorite types of transactions, which I know Jeff doesn't like, and generally not very popular with people, are read-only transactions. Transactions that don't change the state at all, and will just give you a receipt that is a result of like doing some computation on chain, or some lookup on chain. Those types of transactions you will not need any finality whatsoever on, because and you'll just look at the receipts right away. For example, like if you're going to do use a transaction to do a DNS lookup, that would be something where you don't need any finality whatsoever.
Which you would not use a transaction for.
No, that's what you think. But if I have like a massive DNS table, and I believe that we can push the limits of the blockchain to be where it's competitive with decentralized computation markets and decentralized storage markets, then you might.
Yeah, I mean, basically this has to do, it's like cash, right? How stale of a cash are you willing to accept? Right. That's the analogous situation.
Yeah.
So I'm fine.
Only fresh doesn't mean fresh means not fresh means very stale in this case. Right. Less good than your last one.
So I'm fine with the answers. I just wanted to make sure that what we were talking about with respect to the difference between a converged betting sequence that clients can observe versus the state as not being versus a state that doesn't match that as not being labeled an error.
Right.
No, if it's labeled an error, then we have exactly the property that I'm requiring. The property is that you have an equational chain from state, for every reorder, and if you don't, then you label that as an error.
Yeah. No, I think that we're entirely like aligned on this. I think that the main thing that we haven't really touched on enough is the relationship between different betting cycles. Because
no, I mean I think I'm chasing a diagram that around around two arms, right? So I'm considering the totality of the scheduling cycle. So the scheduling cycle that includes, first figuring out the schedule, and the second is the reorder on the schedule, and then the third is the actual execution of that, right? So I'm considering those as a chain of operations which has lots of inner parts to it, and I'm concerned about if you go around that in two different ways, if entities don't come to the same conclusions, they will yell and scream and gnash their teeth and wail.
Right. Yeah, I think that's right. Yeah, because if you come to different conclusions, it's because you see contradictory bets, which means that someone has got to be slashed in some sense.
That's right. That's exactly right. That's precisely it. Otherwise they're like but this doesn't give me any sort of consistency at all, and so now I'm
Right.
why would I ever use this?
Yeah, totally. Yeah. So I think we are, you know, I think we definitely land on the same page even if we're not currently on exactly the same page. It seems like we got a good collision trajectory.
Okay, good. And yeah, so I'm good with that. I noticed that we've been doing this for 2 hours and 10 minutes. Maybe you and I can re-engage after you get some lunch and stuff.
Yeah, that sounds good. Thanks for joining, Piper. It was nice to see you here. Hope you enjoyed
sorry
it.
to be late. I should be on time for.
No worries. Did you enjoy our hangout?
Yeah. I wish I had been here a little bit earlier, but it was good. I'm looking forward to the next one.
We can, see how much preparing we can get done in 60 seconds of a shot.
What was that? Sorry, Aaron. I didn't hear that.
Oh, I was just saying it was great and looking forward to the next one.
Oh no, but Aaron said something after.
Oh.
Did you not, Aaron?
No.
No, okay.
I just activated the video, I think.
Sweet. Well, that's good. I'm glad you enjoyed it, Piper. And the next one I hope will be on Monday, and maybe the next one I will tweet about it before, not just like right the moment it starts, and we might have more live listeners. Do we have any way to meter to like see how many people listen, Greg?
Yeah, you can. You can. The only thing you don't. I mean, you have to go back to YouTube. Well, like once I hit stop broadcast, it'll be published to YouTube, and then so for people who watch it much later, you have to kind of watch the YouTube stats on that.
Cool.
And
that's cool. So yeah, I'm just curious to see if but right now you don't know if we've had any listeners.
We have one viewer.
Sweet.
You know.
Yay!
The Grammys are next, right? You know, we'll be taking the Grammys by storm.
Totally. And did we have one viewer the whole time, or was it like, you know, did we maybe have two viewers during the first half?
I didn't pay attention. I'm sorry. I was on multiple devices. So.
No worries, because I imagine that we might have lost some during the switch.
Well, that's quite possible. Yeah. But I all I could do was we said it in view time that the link will be posted in the comments section on the previous session,
Sure.
which I did. And so,
yeah,
the best you can.
Yeah, totally.
Oh, actually, no, that's not true. When I used to run the Emerald City Music Night, the way I would do it, once I figured out that the lag time was this problem, then what you do is you go ahead and schedule 3 hangouts on air, and then the links are all preset; they're all available.
Right.
So if we know that we're going to run over an hour, I also think that we need to make some kind of distinction between a stand-up, in which is usually like, you know, everyone takes just a few minutes to kind of update on what they're working on, versus what this was, which was more of a, you know, a discussion.
Oh yeah, I agree. But
so that's what we.
I don't want to introduce a schedule that will disrupt flow. I mean, like, I feel like it was the discussion went pretty well. I don't think that there was too many hang-ups, except for maybe we had like a protracted conversation about schedules versus blocks.
Yeah, speaking of protracted, I gotta take off, guys, but this is great.
Yeah,
I really enjoy these discussions. It's like I get a view into what everyone else is thinking.
Yeah, fair enough. Absolutely. Okay, cool. Then the following the flow, it sounds like the right thing to do.
Sweet.
All right. So
I'll see you guys.
All right.
Talk to you later.
Ciao.
See you.